19 says what the classification of an element is based on its electron configuration. That is very similar to something we have already talked about. And for test hint, or test question number 19, you need to know what N stands for. N, our principal quantum number. So if N is the highest occupied energy level, the outer configuration for a group 1 element is going to be what? Well, group 1 is going to end in S1. If it asks about group 2, it's going to end in S2. If it asks about column 13, it's going to end S2P1. Okay? Look at how many electrons over in your configuration using that exponent. And when they say N instead of an actual number, it means in any energy level. Don't make that question harder than it really is. Test hint number 20. How to identify the group number of an element from its electron configuration. I always just looked at the end of the configuration. So if I gave you an example and I said, wow, nitrogen's electron configuration is 1s2, 2s2, 2p3. To what group does it belong? For heaven's sakes, just go over to P3, find nitrogen. That's the pnictogen column, column 15. Very easy question. Test hint 21, how to identify the group number of an element from its electron configuration. Again, okay, so same idea. I'll give you the electron configuration, you find that on the table, find the column number. Shouldn't be too tough. Test hint number 22 says how to write the outer configuration for a given group of elements. So what if I want to know about the chalcogens? And what is their outer configuration? Well, you need to know that the chalcogens are, that's the name of the oxygen family. So you go over here and you see that that is in column 16. And that is 2 elements over in the S block and 4 elements over in the P block. So it would end S2P4. Whether that's 2s2, 2p4, 3s2, 3p4, 4s2, 3d10, 4p4, whatever energy level can vary, but it's going to be S2P4. Test hint number 23, how alkali metals and alkaline earth elements are found in nature. Okay, column 1 and 2, the S block metals. Those are very reactive. Okay? You are not going to find them by themselves in nature. You're not going to be able to dig up a vein of potassium in a mine somewhere out west, like you can maybe with gold up in California. They're so reactive that they bond right away, and typically with oxygen, since that is so abundant as well, although many other things are possible. So they're always going to be in combined form. They're called ores. Like when we dig up iron ore, copper ore even, and we purify those, we separate the debris in the rock and the stuff we don't want from the metal with many different methods. Test hint number 24 says what the most reactive groups of metals and nonmetals are. Well, we just had a question about the most reactive groups of metals, column 1 and 2, alkali and alkaline earth. Nonmetals can be very reactive, just like metals can be very reactive. And you didn't realize that when you started this chapter. Hopefully by now, when we've been through quite a bit of it, you realize that those halogens are very reactive as well. So are the chalcogens. Things tend to be most reactive in the extreme corners on the periodic table, discounting the noble gases, and they become more stable, a little less reactive in the middle. They still react, but not quite as dramatically, as vigorously, as quickly as the N's, maybe the halogen and chalcogen column, and the alkali metal and alkaline earth metal. Test hint number 25. What properties distinguish the noble gases from other elements? You knew this before you even got to chemistry class this school year. The most characteristic properties of noble gases is that they are non-reactive. They have that full outer shell. They very, very rarely react. And we kind of have to force them to do that. But for our purposes in a level 1 chemistry class, we're considering at this point in our understanding that they are not reactive. Test hint number 26. How the alkali metals and alkaline earth metals compare in properties, okay? So they both have just electrons in the s orbital. They're both very reactive, fairly soft silvery gray metals. The column 1 are softer, more reactive than column 2, although very similar, say compared to something in the transition metal D block or the F block. And if we're comparing one to the other, we might say that the alkaline earth elements in column 2 are a little bit less reactive, although they react in very similar ways. All right, test hint number 20.